Okay. I want to welcome you all to the January 2022 ERISA Texas Speaker Series. We've got a great presentation today. We have John May is going to be presenting his second presentation. This one is on advanced SQL Server database topics. We had a great presentation last time, but left it with a lot of questions. And so John is here to address those. He's going to be looking at building on the past presentation, the enterprise database tips and tricks. And as you all saw within the request to attend the presentation today. So John started his career with the U.S. Forest Service in '89. He's been a long time GIS expert, University of Georgia. And he also has worked for national engineering firms. So I'm going to go ahead and turn it over to you, John. We appreciate you being with us again today. And again, put your questions into the chat window and we'll make sure they're addressed at the end of the presentation. Thank you, John.
All right, well, I'll go ahead and start. Since I can't see a chat window, if one of y'all are monitoring it and if a question pops up that you think you need to throw out while I'm talking, just throw it out and I'll answer it right then. Otherwise, I can try to get them at the end. So today's presentation builds on the last one. I, unfortunately, like the last one, have a lot of big topics I want to cover. I could do more than an hour on any one of these topics, but I'm going to try to compress it, walk you through quickly, and show you what stuff will look like. And, the intent here is to kind of stir some of your creative juices and give you enough resources to where you can go out and become dangerous, okay? So one of the important things you're gonna wanna do when this is all over, with the folks, they have a copy of the presentation, and inside the presentation, I have a lot of copy and paste SQL code and also links to external resources that you probably will find useful along the way. I know there are things that I regularly use. So today what I want to talk about are these four areas. I want to touch on all four of these. First is triggers and some important things to consider when you're doing triggers and what you can do with them. The second are views inside of your database, and views are really handy for doing a lot of different things. I'm going to show you how you can make either a spatial or a non-spatial view. And creating one is pretty straightforward. The third thing, and it's a big thing, is integrating your existing enterprise database with SQL Server Reporting Services. Now, whether you're using an Oracle database or a SQL Server database, the rules apply equally here. Because SSRS can connect to either one. It can actually connect to other sources besides that. But I'm just going to make the assumption that that covers the majority of potential users. And the nice thing about SSRS is that you can actually make really powerful and meaningful reports and integrate them with your web mapping applications. So you can access reports from your web map. And then lastly, I want to touch lightly on the concept of making measurements. Since all the data we publish in our web maps usually is WGS, that makes measurements an interesting approach. So I'll show you a hack, a SQL hack that gets around that so you can get some correct measurements back out of it. So with that, I'm going to go ahead and kind of launch into this first thing, which is I want to, at the beginning of the presentation, and I'm not going to spend time on this, I'm just pointing it out, put up some links that I find. This is the order in which I go to them. I always go to Tech on the Net first, then W3 Schools, and finally Code Academy. If I ever get tripped up on something with SQL, or I'm trying to figure out how to do a workaround on something. So those are SQL resources. This is important stuff to be familiar with when working with your spatially enabled databases. So the top one, of course, talks about SQL Server database limitations. I know last time we had a lot of conversation about the lengths of field names And apparently I created a stir because I said use long names because they mean something, you know, as opposed to short abbreviations that might not have any meaning to the person beyond the designer of the database. So people were asking, well, how many characters could you use in a name? Well, I think in SQL Server, it's 128, which is awfully long. But anyways, short story is if you go to the top link, you can get the rundown on everything that has to do with the SQL Server database. All the limits and limitations are there. The other thing that's important to know about, and I make a lot of use of in SQL and in report writing, are ST geometry methods. So if you don't know what ST geometry is, go to the Esri link and they'll give you an overview, and then I'll give you the opportunity to click through and become more familiar with what ST geometry is. And then of course, Microsoft, because the ST geometry is actually a native SQL Server implementation. So there's obviously a lot of help on the Microsoft website too. So you can go there and get familiar with that. So that's that. Now, here we go. We're going to start off with triggers. So the first thing and the most important thing that I think you should be aware of with triggers is that you generally want to try to make sure you use one, right? I don't mean one for your whole database. You can apply a trigger to any table in the database. So let's say you have a feature class, we'll call it fire hydrants, right? So you have a feature class named fire hydrants, and you want some magic to happen when a person adds a fire hydrant to a map. Maybe you want the map to figure out what zone or council district that fire hydrant falls within, and other things like that. Well, you can implement that with a trigger. So you don't have to ask a user for information, you know, like tell me what zone it's in. The database can actually figure it out for you. So you would build a trigger and deploy it on that feature class. And then depending on the parameters you set up in the trigger, when something happens to that thing, it'll get executed. Now, things you need to know about with regards to a trigger or just deploying SQL inside your database. You never, ever, ever really want to create any new records in any SDE registered tables. So if you have a table that is a feature class record, you know, you can insert a new row of data into it such that it would be correctly formatted. However, if it's participating in the SDE business functions, you may risk corrupting your feature class because the Esri tools did not create that insert point. So what you want to do is avoid any operations that create new records, which is not to say that you cannot update existing records. You can update attributes and other things using SQL to a registered SDE registered table. I want you to think about, when looking at these examples, the order in which SQL is executed. That's important to think about if you have processes within your trigger that depend on the presence of information that would have been developed by another process. So you want to put them in a logical order so that they can all execute correctly. Always, always, always test your trigger with select statements in the database using SQL Server Management Studio or a similar tool. You want to verify what the trigger code will return, right? So you'll do that by writing select statements, comparing the results to what you think you want, and then saying, yep, that's good. And then you'll update your trigger from that. You'll create your trigger from that. And then finally, it is entirely possible, and I do this regularly, you have a trigger on one table that will make changes or updates in another table that has a trigger applied to it. So think about the effect of cascading triggers. That's important to remember when setting up your database design, right? So let's say you have a feature class, and then you have related to that feature class a table for recording inspection information. And let's say that when an inspection is added, you want the trigger on the inspection table to go ahead and make some changes or updates to the feature class table. Well, depending on how you set your triggers up, that may fire your trigger in your feature class too, which may or may not be a good thing. It just depends on how you design your triggers. So let's go to the example here. The first thing I want you to look at here is I have a simple template, right? Trying to make this easy to use that you could actually copy out of this and experiment with. So this template will let you create a trigger. If you look, and I can already see a mistake I made, that first thing where it says database name, I should have highlighted that in yellow. Those are things you'll need to change the name of to match your environment. So you can create a trigger, and what this line of code says is create a trigger and you give it a name. So that's what you see, a table name underbar TR. That's the name of the trigger. And then you specify the on operator, and then you say the name of the table you want to create the trigger on. So in this case, let's say you want to trigger on a fire hydrant feature class. You would say create trigger fire hydrants underbar TR on fire hydrants, right? So that applies a trigger to that feature class. The next line says after insert, update, or delete. What that specifies is that this trigger will execute anytime a new fire hydrant is created, and anytime a fire hydrant is updated, and anytime a fire hydrant is deleted. So you don't necessarily always need all three of those. You may just want to have a trigger that gets executed when a new record gets inserted in the database. So you would just remove the update and delete, and just say after insert, execute this trigger. There's some business here, setting the no count to be on. You just want to do that so that you don't have any possible errant SQL statements interfering with the execution of the trigger. And then here's the meat of the trigger, right? I have a very simple example here where what I'm doing is when the trigger executes, it says update point feature class. That's the fire hydrants, right? Set latitude equals shape.sty. Now shape.sty is an ST geometry call. .sty is an ST geometry call you can issue against the shape column from your feature class. And what that'll do is it will return the latitude. So I have a field in my feature class called latitude. I have another field called longitude. This is very similar to the tool you would use in the table add X coordinate and add Y coordinate, except this does it automatically, right? So it's going to add it when you create a new record or if you update it. That's the other thing. If you have it on update, that would be handy. You know, I've gone to the attribute table and added an X and added a Y. Then of course, if somebody moves a point, the X and Y does not get updated. You'd have to recalculate the geometry. In this case, the X and Y would automatically be updated because you also have this trigger executing on an update. So that's all important to consider, but this is just a simple template. Now, I'm going to shell out here and show you SQL Server Management Studio. So this is SQL Server Management Studio. I've already logged in just to save time, right? And this is a database. There's all kinds of goodies in here. These are the tables. Now these, you'll see a lot of these SDE branch tables and things like that. That's actual stuff that you never mess with at the risk of messing up your database. So you leave them alone. But then I have all kinds of tables, relationship, tables and feature classes in here. And if I come to this one here, here's a feature class named D5 outfalls. And if I would open it, it would show me all the columns that make up that feature class. Those are the attributes, right? Now, I have here a trigger. So this is obviously large. So I'm just going to kind of walk you through some of the things here. You have the business end of the trigger here. It just drops the trigger if it already exists in the database, then creates it, right? That's always good business. Now, the next thing, I have a trigger is made up of usually update statements, right? So here's my first update statement. It says, when something happens in the outfall table, I want the outfalls to figure out what drainage basin they're located in from that feature class right there. Okay, so I have a feature class called WMD Basins Counties. And what I'm doing is I'm using the geoprocessing tool that's built into the database, where I'm evaluating using the ST within operator. And that is part of your ST geometry functions. Like I said, you can read about those on the Esri or Microsoft website. And so I'm saying outfalls.shape is within, and this is a polygon feature coverage. So if outfalls.shape.st within falls within a polygon of WMD basins counties, it returns a value of 1. So I can use that to create a join, and then I can grab the attributes from this feature class and copy them over into my outfall feature class. So this feature class is actually a union of a whole bunch of different polygon feature classes, just so I can get them all stuffed in there in one feature class and grab the attributes I need. Here's another little operation gets run. It creates a unique facility ID globally for each record. This is not an object ID or a global ID. This is a facility ID that follows a naming convention that the state wanted to use. This trigger sets up a link to an external resource. This trigger, and we'll see this later, actually calculates what the link is to the SSRS report on the SSRS report server. So that's an important one to have. Here's another good example. Let's say you deployed a database and you didn't say, set up a default value for a field and you don't want nulls in that field. You can set your trigger to say, well, if that thing is null, and go ahead and put a no in there, which is what I want for default. Same thing for that. And then finally, this is doing an update on the feature class by joining it with a non-spatial table based on, District 5. So all it's doing here is grabbing attributes from one table and copying them over to another where the join is satisfied. And then lastly, this simple example in the trigger I did earlier, will update latitude and longitude. There's some more, there's another trigger being built on another table down here. I don't need to walk through that. What I can do is copy this and I can open up a query window. I can paste it here. And I execute it. And then it's basically, I've got no error messages. At the end of my trigger, I always like to put in some little analysis that just tells me what just happened, what triggers got created, so on and so forth. So now that trigger's been deployed, I can come over here to Collector and we can see how it works. So I'm zoomed into a map here, right? And we're just gonna go ahead and add a dot right there. We're gonna say it's called test. It's on a road, it's a ditch. And I could submit it. And what I've done, just, oh my goodness. There you go. So if I click on it now, remember I just filled in a couple attributes, but now we have a bunch of other attributes that the trigger has built for us. It created that ID. It figured out what county it was in. It figured out the latitude, figured out the longitude, figured out what drainage basin it's located in, what maintenance yard serves that area, and it built the link that goes to report on a report server. Now you see here the date the last inspection was performed, the last inspection result. Well, I just added that. The thing hasn't got any inspections related to it. What I can do is come here and add an inspection.
John, question here. Can this be used in new field maps as well?
Yeah, it works in field maps. So I've clicked on it. You got to click on it to force it to refresh. And now you'll see here, the date the last inspection was performed has filled in as an attribute for the outfall, and the result of the last inspection has also filled in for the outfall. This is especially handy if you want to symbolize your map data with information like inspection results from an inspection table, right? You can have a trigger that copies the last inspection, the information you want, like the date it was done, the result of the inspection, right into the attribute table, because you can't really have server-side joins working on your published web maps. So this would make it easy to symbolize your data based on last inspection results. And you're not having to think about it. This is, it gives the user a chance to have minimal input and get maximum data back out. So that is that part. Yeah, go ahead.
Yeah. Amy had a quick question for you, and she was asking if you're aware of a way to create view modified triggers inside ArcGIS platform. She said the SSMS method makes perfect sense, but she's just wondering if Esri has any skin in the game on this.
Esri won't allow you to do this if you're just using ArcGIS Online. Is that the answer? Is that the question?
I think so. What about Pro?
Well, if ArcGIS Pro can connect to your own hosted database, or you can be connecting to ArcGIS Online. ArcGIS Online is this. It's an instantiated, they're actually using, I think, Amazon Web Services, but inside this database, I can have numerous databases. So what ArcGIS Online is a collection of databases inside a database container, and you as a client have access to your database. But what they don't allow you to do, or at least at last I looked, they don't allow you to connect to it using something like this to make modifications like I'm showing you. Does that make sense? So if you only are using ArcGIS Online as your data repository, you're not going to be able to connect with SQL Server Management Studio. You need to set up your own SQL or Oracle database, either in the cloud or on-prem. I would always recommend cloud because it's so much easier and so much scalable, right? And so inexpensive, at least to get started with. You'd have to have your own environment, your own database environment. So I hope that's the answer. Well, I don't know if that's the answer you want, but I think.
Yeah, we've got a few more here, and I'll save them towards the end, but we'll let you. I didn't want to interrupt you too much.
Yeah, no worries. So that's triggers. Next is I want to talk about is database views, right? So views are pretty cool, and I use them a lot. So highlights, right? There's certain rules about a database view, things you should be aware of. You can make a view of data that is spatial, meaning that it's mappable, or non-spatial, meaning that it's just a snapshot of data, right? Not mappable data, no shape, field, or anything like that. But any SQL query you can use to pull data together, analyze data across tables, you can use to make a view so it's always available readily. Like I said previously, you can use a view to map on your web maps, right? That's especially handy when you're aggregating data from multiple sources, right? You can make a view of that, especially if they're resubmitting it to you regularly. You can make a view, and so as they resubmit, your view always self-updates. You can also use the view to show real-time joins on a web map. That's another handy thing. Your view can actually join multiple tables together, and it can be integrated with your web map. Another thing that most people don't think about, since you're going ahead and making the view, you can put more than one type of geometry in the result. So you can actually have a view that has both points and lines in this on the same row. And then when you decide to look at that view using ArcMap and publishing it, you pick the shape field you want to use for the data that you want to show on the map. Or you can show them both on the map as two different layers, one a line layer, one a point layer. Views do not have to be registered with SDE. So you can either create a view using something like ArcGIS Pro. Well, I haven't done it in ArcGIS Pro, but ArcMap, you just go to the database, right click, say new and select view, and you put your SQL into the little window there and give it a name. Or alternatively, you can deploy a view. I'll show you, in a database. They don't have to be registered with SDE though. And then finally, you can use a view to transform data. And the easiest way to explain that is, let's say you're getting regular submissions of data where column names don't line up with the column names you need to be showing on your map, right? You can write a view that takes their input data and transforms it to match both data type and column names so that it more easily aligns with your information. That'll save you a lot of time, especially if this is a recurring thing. More on that later, so let's see. Here is a simple template for making a view. You have your create view statement, then your database.view name. View name is whatever name you want to use. Now, this is just my rule. I always prefix my view names with the word view. So if I have a view on a feature class, say fire hydrants, I would call my view fire hydrants, right? So all the views will appear in your Arc catalog window. And if you don't prefix them all with the name view, they'll be scattered around, okay? So if you want to see all your views clustered together, prefix them all with the name view, and they will. So to create the view, it's just a straightforward select query in the in SQL world. You select. Here's the one thing you're going to need is some type of unique field. In this case, I'm selecting the object ID, right? Any other attributes that you want to see on a map. And then finally, the last thing you want to select, if it's a mappable, right? You want to create a view from a feature class to see on a map. You want to select the shape field. And then you select that from some feature class, right? So that's pretty straightforward. Things to think about. Object ID. If you are selecting and unioning two or more feature classes, the object ID field won't work. So you'll have to do something else, and I'll show you, to come up with your own object ID. Because what'll happen is you're gonna have to tell, when you draw that view on a map, what's the object ID field. The software's gonna ask you for that field. You wanna select something that is guaranteed to be unique across all sets of records that exist within the view. So two feature classes would both have a record with the object ID number 1. So even though you can write a view that puts them together, that object ID is now not unique in the collection, and the map will only show the first occurrence of it and ignore the second one. So you want to make sure you maintain uniqueness across whatever field you want to use. If you've implemented global IDs in your data, then you could use, instead of the object ID field, you could use a global ID field, and that'll be guaranteed to be unique across all observed rows of data. This will create, let's say you have a table coming in, some frequency, and that table has a latitude and a longitude value along with some other objects, right? You can create a mappable view from that table with this select statement right here. So the very first line I'm showing you here, and I can't highlight it, oops. It says cast row number over order by select null as integer, right? As object ID. So I'm creating an object ID field that's going to be guaranteed to be unique and sequential for every row in the table that's an input, right? And I'm creating it on the fly. The next, after the comma, the next thing says FC, feature class, dot attributes, right? And that is whatever other attributes you want on that table. You name those. Then this, I don't know if you see my mouse, I say shape equals geometry. And then I'm issuing a call. This is another one of your ST geometry methods that I talked about at the very beginning. We're going to use the method of ST point from text. And what this method does is it creates an ST geometry object as a point from input text. And this is the actual, if you had a table named FC with a longitude column and a latitude column, you can actually create a shape by copying this code right here, and it would work, okay? This would make you a mappable point feature class, because what it's doing is it's creating 4326 is WGS. It's creating a geometry object as a shape for each row in that table, right? And it's going to make the latitude and longitude your mappable points and WGS coordinates, and you're ready to go. So your view would have a name, right? Whatever view you want. And this is the select statement, the SQL. Now, as I mentioned earlier, here's an example. You can this is another example. You can make lines. Let's say you had a very simple collection that had beginning coordinates and ending coordinates that define lines. This is the exact same procedure as the previous one, except in this case, I'm using the method ST line from text. It'll make a line string. And so this is how you would make it. And now you had a view ready to see lines coming from a table. This is the tricky one, but it's not really that tricky. I'm combining the previous two to make one. Let's say I have a table that comes in. This is a real world example. Comes in nightly. It's got more than 1 million rows in it. 1 million rows of data. And each row of that data has coordinates. One coordinate pair represents a location on the surface of the earth. And another coordinate pair represents a location under the surface of the earth that represents the bottom of a well. And you want to see a line that shows from the top to the bottom, as well as a point that shows you the top. So in the old days, you would use a model builder and then build feature classes, and then it would run for hours every night to, update these feature classes from the data that comes in nightly, because this data is being updated nightly. Or you could do this. You can create a view that reads that table that's updated nightly. And this view dynamically creates the point and the line all in one table, and then you map them both as different layers on your published web services. And now you see your points and your lines from one table that you never have to update again, because it updates itself every time new data comes in. So it's a big time saver, and it's handy as heck. So I love them. So let's go with how do you make a view? Here we go. So here's an example of creating a view. It says create a view, right? I'm giving it a name as, and then I have this big select statement here, right? Everybody see that, right? So let's look at the select statement for a minute here. This select statement is doing a couple things. What I'm doing is I'm selecting data, in this case, from another view to make a second view. This is data, all my query here is coming from a previously made view that is aggregating data from many different sources. That data has been aggregated, and now I want to have another view that reformats this data into a format that meets up with another business need. So what this view is doing is the first thing, obviously, is it's creating a unique object ID for every row selected. Then there's a lot of case statements. It says outfall type equals when data in the other view, when it says that column equals yes, then my output view says the outfall underbar type equals MAJ. And this is what I hate about coded domains. MAJ is a coded domain that the other people set up. They set up MAJ to mean major. So you want to transform the data to match the codes they set up. So these case statements are meant to do that, right? So outfall description, outfall underbar DESC, that's their database design. And then we'd say, well, when our data says in-wall, then theirs will be EW. When the input data says box culvert, it'll output to CV. So on and so forth. This is just cleaning up nulls in a view. So if there's nothing there, we'll set it to 0. Otherwise, we'll cast the data as integers. We'll go on and so forth, all the way through, right? Now, I've already deployed this. But what I can do is, let's just, for the sake of running it, let's hope I don't have an error message here. All right, so I just ran that view, right? So now I can say, and then there are the results of the view, all clean and neat. At this point, you can actually, if I had a shape field in there, I do. No, I don't actually have a shape field, do I? This is for a spreadsheet that goes out. But I could have added the shape field in my original query. Thought I had the shape field. No, I took it out. But if I added shape, right, I could just say, hoop. Oh, and of course, oh, yeah. I'm going off script now. All right. Now the shape field is there. That view is now mappable, and it's been transformed into a mappable element that matches up with another database design. So that's the handy thing about a view. Another thing about a view, let's see, what I wanted to do was show you how you can aggregate data with the view. So this data, now I'm connected to so many sources. There's, trust me on this, even though it looks like there's 7, there's 8 separate districts. 8 separate organizations are collecting data into 8 different data environments. But what I needed was one map that all 8 appear on, and I don't want to manage all 8 individually. So I make a view that aggregates all 8 together. And then what will happen is you zoom in, because we got so many things, you got to wait for the map to refresh. They'll appear on the map, right? And when they appear on the map, you can click on an object and retrieve data from it. There's data, right? So that's all coming from a view. Now, I got to cheat on my notes here. I think my next thing is I want to jump to, because of time, is integrating with SSRS. So SSRS stands for SQL Server Reporting Services. Simple things. Visual Studio Integrated Shell is what I use to author all the reports. You can get it for free from Microsoft. It will work with Visual Studio 2016 and earlier. I keep forgetting that. Attribute reports. When you want to have reports coming out of your data environment, you'll have to parameterize them, but that's really simple. I'll show you. You do need SQL skills. So you can roll back to the beginning of the presentation. And if you need to brush up or learn more, follow those links, because your reports depend on SQL writing. You can link your reports, and I showed you this earlier. So when you add a new record to a feature class, the trigger builds the link to the report. You can map spatial data on the report, and my last comment is the Wild West, because you can do almost anything with the report once you figure out how to use it, and it's not that complicated. So handy, let's go here. This is the Visual Studio shell. So let me, let's go here. So the Visual Studio shell is pretty straightforward. You create a project, you give it a name, you set up a data source. This is the same information that you would use for your your SDE connection to your database. Then you would create reports. Now, I've already created some demo reports here. So here's a report. A report has parameters. It can, it doesn't have to, but it can have parameters. It has to have a data source. So in this case, this data source is pointing back to here. And then it has, in this case, this report has four different SQL queries that have data for different elements of the report. This query retrieves data. It's a reasonably long SQL query, retrieves data from the database. It accepts some input arguments so that I get the data I want, right, from a parameter that will ask the user to input information on. This particular SQL query scans about 80 or 90 different tables and views in the database. And then what it actually does is it aggregates and summarizes the data for a range of time. So I'll just, quick demo, let's see here. I'll say from, it's accepting a range of dates because it's going to look at a range of dates. Now, when I select that, this list here says this is a list of all the valid permit numbers for that district. And then the report runs. And like I said, that's 5 or 6 seconds. It's reasonably fast. Of course, I'm on a slow connection right now, but this whole big block up here, this business right here, that is a result of scanning loads of tables within the database and loads of inspection records to figure out how many things there are, how many were inspected between those dates, what the relative percentages are. Another nice thing is the report supports drill down capabilities. So I could say, aha, drill down. How many pages is this? 5 pages, right? So
John, we've got about 12 minutes, just letting you know.
Okay, so every one of these is clickable. And it goes to the link, and then I can drill through and the report. Now I'm actually in another environment. That's a Bing map, right? It's actually put that location on a Bing map as part of my report. So how to access these? Well, you can have a web map, and here is the link, right? If I click on that, it goes to it. Alternatively, you can have non-spatially related reports that you want to integrate. And this is what I did. I used the About window, and then I have these things. And now I have the same report I was looking at earlier, right? Different bucket of data from a different environment. And then I say, I'm interested in seeing that one. You can drill through. Oh, yeah, that says it has 5 pages. Oh, it has photos attached to it too, right? Nice thing about reports, you can also save them off locally as Word or PDF files. So you can do a whole lot more. But because of time, I am going to go lastly to the hacks. Get these. You'll want to know how to do this, because if you want to put on your report how long an object is, you're going to want to calculate what its geographic length is, not its geometric length. So this hack will let you convert a line to real Earth feet. This hack will let you convert a polygon to real Earth acres. So if you want to embed those in your report, you can. You can also add something like a link to Google Maps on your report, right? So quickie example might be this. So I have here, I'm in a report preview window here. That's a Bing map layer, but somebody might say, I want to see that on a Google map layer. Well, if you email them a copy of that PDF, it would have a Google link built into it. And then they can do whatever they want to do, like get directions to there from wherever they are, blah, blah, blah. So those are handy hacks to know. I've done that. So last stuff, SQL training. These things are good. I've attended a couple of these and found them useful. I'm the kind of guy that I train myself and then I go find a class and take it to see what I missed. So these are links to what I think is training that would be very helpful for anybody. You just follow them and they'll tell you what you want to know. And I'm at the end of the slides. So, hey, I rushed through, but I've got time for questions.
Perfect. Thank you so much, John. That was very knowledgeable and well received. So we've got a number of questions here. We've got Addie and Christina, if you guys want to jump in and help me monitor this. The SQL training, John, are they for beginners or you got to have some knowledge already?
So if you go at the end of the slideshow, they have both beginner and advanced training at those links at the online training centers, the ONLC. Also, if you, at the beginning of the slideshow, the SQL Resources, Tech on the Net, and the W3 schools, they have tutorials that are very good, introductory basic tutorials, and I'll walk you through it.
Okay, let's see here. How do you share this SSRS with other users who don't use a GIS or a SQL?
So the way that works is, so SSRS is going to actually be hosted and run by your organization. You can deploy it either in the cloud or locally, right? And then what you'll do, you have a login for it, right? Depending on how you want to make it available. If you want it publicly available to the whole wide world, you can do that. I don't recommend it. Or you can create a user group, an Active Directory user group for your SSRS report server. And then you add whatever members of that user group that you want to have added that need access to the reports. When they run it, they just enter their credentials and they'll see the report. So pretty standard fare for, logging in to the website. You'll see a username and a password request.
I got a couple here. I'm going to tag them together. Gennady asks, does anyone know of any resources for creating reports or image services? And second part is, Samantha says, is there any way to set up a trigger to send an email to a list of users when a new point is added?
Yes, you can. We're doing that. So we have some, it's not a trigger. What it is we have an automated report server that's part of SSRS that runs nightly. And depending on the condition we're monitoring for, if a new maintenance request is logged, it generates an email with the pictures and a location map, and it automatically routes the email to the people who need to get it, right? So you can do that. You can also set up a report so that what it does is it scans the database for new records. So if this and the previous question was, if a new record gets added, notify somebody. Well, if you have enabled the create date, right, field on your feature class, then what you do is you set up a nightly job that scans the database for that feature class, and anything where the create date is, the same date as the day it's running, right? Then it can automatically send out an email notification to whoever you want it to go to, or a listserv even, that a new X got created. So you can automate that.
Okay, perfect. Okay, real quick here with 5 minutes to go. When creating a view in ArcGIS Pro, is it possible to combine fields from separate database connections?
I don't know about that. I am doubting it. Generally speaking, it's a lot. Okay, so for instance, if I'm in here, right, this is a database connection. That's the actual name database, DOTSLSQLS, right? So that's a
I
database.
can actually, I just did one last week, and yes, you can. So I just wanted to jump that out there. You
Nice.
can, yeah.
Yeah, I haven't done that because I know if I was in Azure in SQL Server, I have to do a few extra tricks to get data from one database combined with data from another database. I have to set up an intermediate table, right? To do that. Now, if you're in ArcGIS Pro, that's one thing. But if you're writing a view, I don't know about that.
Okay. Very nice. Yeah, well, we might have to follow up on that one for sure and see if we can get that as a later presentation. But hey, I got a quick question here. Let's see. It says, hey, if you can ask this question last, if there's time. My colleague says that she already uses triggers in Oracle, but describes them as flaky, okay, per se, as in works sometimes, doesn't work sometimes. Have you observed any issues with triggers in Oracle versus in SQL?
No, I've done them in both environments. The number one thing that influences the trigger would be the contents of the trigger and the platform that the database is deployed on, right? So, and by platform, I mean the resource, the database resources that are allocated to the database service, you know, that the trigger resides in. So if it has limited resources and a lot of users connected to it, you could see real slow performance. Unfortunately, both in SQL Server and Oracle, if performance is slow enough, something could time out and the trigger may not finish executing. That's in my world, that's just been rare, but I have seen that kind of thing happen. But as far as just being generally unreliable, I've not had that experience.
Okay.
But like I said, you can write a trigger that can give you headaches if you're not careful about what you put in it.
Let's see here. Do you have any links or go-tos for some walkthroughs for creating reports from scratch from Visual Studio? Any?
Oh man, no, this the integrated shell is just really, if you've been exposed to like Crystal Reports or exposed to like Microsoft Access, you know, the report writer in there, this is pretty similar. You know, I can say I want to add a new report, and then, you know, I can use their wizard, right? And I can say I want to use that data source, or I want to do that, you know. And so I could say that, and I could say whatever. I could put my SQL query in there. You know, you can walk through and then have the basics of a report, right? And, you know, give it a name. And then from there, you can open it up and edit it. You know, hey, you know, make changes to it.
Nice.
And then
Okay.
modify. And really the modification, you see your objects down here on the left, right? You can say, hey, I can add text boxes, I can add lines, gauges, charts, whatever, you know. So there's all this kind of stuff. You can do it. Not too complicated.
Well, fantastic. So, well, we're pretty much here at time, John. We really appreciate you giving a fantastic presentation. And inside the chat window, a lot of folks are just thanking you and saying awesome presentation. And yes, we will be putting this up on our YouTube channel. John is graciously let us going to put the PowerPoint presentation up on the Eurista Texas website. As we mentioned earlier, we're looking for volunteers, so please, the QR code, go to our link that we'll post here in a second. And if you want to be a volunteer for Eurista Texas, by all means, get involved. It's a great network of really skilled professionals. So we appreciate everybody attending. We'll be back here in February on the 22nd of February with Rafael Hernandez giving a great presentation on his award-winning Esri presentation for lead pipes in the city of Louisville. And other than that, we'll let you all get back to your day. But John, again, thanks so much. We really, really appreciate it. It's a great presentation.
It's my pleasure. If anybody has questions, forward them to me and I'll try to provide answers.
Okay, and I would like to go ahead and thank my co-hosts today, Christina Dietz and Adeline LeBron. And they both are with Urissa, Texas. So again, we will see you all next month. And John, take care. Appreciate it.
All right. Thanks. Have a nice day.
Okay, take care, y'all.